Bismillahirrahmanirrahim. Assalamu alaikum viewers. You are watching YouTube and Facebook channels of Professor Dr. Rizwan Jamil Qureshi. Welcome to the lecture number 34 of Software Economics course. I already covered the role of people in managing the projects. The topic of today's coverage is the second P is the product. Product means software. The scope of software must be established in terms of context, information, functions. The context I already discussed during the project introduction document when I covered the project specs. What are the existing systems running at the customer side and what are the constraints regarding the integration of the new system with the existing system. For example, architectural constraints, platform constraints, integration constraints, language constraints, and then information objectives in terms of inputs and outputs. Then what are the main functions, main modules of the system? The scope must not be ambiguous, it should be clear, it should be understandable, it should not be confusing, it should not be changing at the customer side and at the software company side. The next is problem decomposition, that we divide the main modules into sub-modules. It is also called functional decomposition or stepwise refinement. So we divide the main problem into smaller problems, into pieces, chunks or procedures. We have to consider two major areas of problem decomposition: the functionality that must be delivered and the process that will be used to deliver it. We call define quality attributes for software. For product, we have functionality, dependability, maintainability, flexibility, portability, usability, efficiency, integrity, acceptability. Functionality. The product must function according to the customer requirements. Customer must be satisfied, customer must be happy. Dependability. Dependability means software must be trusted by its users. Dependability system requires the trustworthiness. How the customer can trust on a software. Dependability means a customer can trust on a software. How we can trust on a software? So we have 7 dimensions of dependability. The first one is availability. Software must be available to its users 99.99%. For example, Google, Hotmail, Yahoo, Gmail. Reliability means software should have minimum bugs and it must be stable, it must not crash again and again. The best example is Linux, Unix, which are highly reliable. And if we talk about unreliability, Windows is highly unreliable. So Windows crash again and again, whereas Linux, Unix, Mac, Sun, Solaris, they are highly reliable. The reason Microsoft has architectural problems and the bugs in the architecture are inheriting in the upcoming Windows, and Microsoft did not change the MFC Microsoft Foundation classes, whereas Linux, Unix are open source, so thousands and thousands programmers, if any bug is reported, they try to fix it. So that's the benefit of open source, and because of that Linux is highly reliable. Safety. Safety means the human life risks are covered. So it has safety measures. For example, we have safety critical projects where human life risks are involved, like fire alarming system, nuclear reactor control system, flight control system, car airbag system, or safety measures in the car. Security. So safety is regarding the risks that are related to human life, where human life risks are involved, whereas security is for data theft, that we have considered the security and we have implemented the security technology, that who are the users, what are the ranges of accessibility, what kind of security technology we have implemented. Availability means the ability of a system to deliver services when requested, when required. Reliability means the ability of a system to deliver services as specified, and software should have minimum bugs and it must be stable. It must not crash again and again. Safety. the ability of a system to operate without catastrophic failure. That means the ability of a system to protect the loss of human lives, like the flight control system, fire alarming system, nuclear reactor control system, space shuttle system. Security, the ability of a system to protect itself against accidental or deliberate intrusion, that ability of a system to protect itself from unauthorized access. Repairability, survivability, error tolerance are the other dimensions of dependability. Repairability means reflects the extent to which the system can be repaired in the event of a failure. Survivability reflects the extent to which the system can deliver services while it is under severe attack, and it should have the same functionality with the same efficiency as it was before the attack. That user should not feel that system is under attack. Error tolerance means exception handling. The user input errors can be avoided and tolerated. Validation checks have been implemented. Maintainability, the ability of a system to easily maintain in terms of corrective maintenance, adaptive, perfective, and preventive. I already covered corrective, adaptive, perfective, and preventive. Corrective means the bug fixing, easy to fix the bugs. Adaptive means software can be easily adaptive to multiple platforms, easy to run on multiple platforms. For example, we developed software for Windows and customer requested the software company to run it on Linux or Unix or Mac or Sun Solaris or Fedora. We have to change at the API level to run it on multiple platforms in terms of operating system, in terms of web server, like we have Microsoft Internet Information Server, and customer asked the software company to run it on Apache or WAMP server. Perfective means easy to update, easy to upgrade. Preventive means we perform maintenance to improve the quality of software. It's like we have legacy system, and after 10 years, 15 years, we need to perform preventive maintenance to improve the quality of software in terms of efficiency, performance, reliability. It's taking more time to load, or more maintenance is required in terms of corrective maintenance, because during the life of software we perform corrective, adaptive, and perfective maintenance, so its quality goes down, it's deteriorated. So we need to improve the quality of software. Flexibility, extent to which the software or product is easy to reuse. We can reuse a software, write once, run anywhere. So that should be the ability in the software. Portability means it can run on multiple platforms. So we have adaptive maintenance to make it platform independent. Usability means easy to use. We should always try to increase the usability, like Microsoft Windows usability is very high. Efficiency, how fast, how quickly a software responds to its users is called efficiency. Like Google is highly efficient and most widely used search engine in the world because its efficiency is in milliseconds. We have two types of integrity. We have data integrity, reliable, and application integrity mean how much of security technologies have you implemented, like firewall, digital certificate, antiviruses. Acceptability mean how much users are satisfied from the product. It should be above 60%, then it's accepted by the users. So we already covered people, product. The third P is process. When we want to start any software, we need to consider the methodology, what methodology we are going to use it for the software. Sometime we have to implement a methodology as per customer requirements or characteristic of the product itself, or the customized methodology software company already using according to the mission statement of the company or the goals of the company, the environment in which software team is working, customers who have requested the product, and people who will do the work. Customer can suggest or the team can suggest characteristic of the product, its safety critical project or similar to previously completed projects, or it's a re-engineering project or scratch based development, tight deadlines. There are different reasons, there is different criteria to select a methodology. The process. Once a process model is selected, project planning activities are started, and then we do the functional decomposition. We have the SDLC phases. The fourth P is project. Use common sense approach. Start on the right foot. Understand the problem. Set realistic objectives and expectations. select a good team, maintain momentum, provide incentive to reduce turnover of the people. We want to retain the team members, and you have to give them rewards, appreciations, motivations, emphasize quality in every task, and have senior management stay out of the team that they are using pull strategy or they are using push strategy. Track progress, track the completion of work products, collect software process and project measures, assess progress, planned versus the expected averages. We have different techniques to track progress: earned value analysis, formal technical review, post-mortem analysis. Make smart decisions, keep it simple, use COTS, commercial off-the-shelf systems or existing software before writing new code, follow standard approaches, identify and avoid risk, allocate more time than you think you need to do complex or risky tasks. Risky tasks are entertained first, are developed first. So if there are bad news, they should come early. Conduct review sessions, post-mortem analysis, formal technical review, walkthrough, sprint review, sprint retrospective, collaborate, deliver, reflect, improve, plan, do, check, act cycle. Track lessons learned from each project, compare planned and actual schedule, so you have cost variances and we have schedule variances. Get feedback from the team member, use metrics, customers' feedback, the project signs that it is in jeopardy, the signs that indicate that project is in danger. The people don't understand the customer needs, scope is poorly defined, changes are managed poorly, technological changes, business needs change or are poorly defined, deadlines are unrealistic, users are resistant, reluctant because they feel if software is developed, we will lose our jobs. The job threat is there. Sponsorship is lost. The investors stop funding the project. The team lacks people with appropriate skills. They are not well trained. Managers avoid best practices and lessons learned. 5W and 2H principle is there regarding the project. Why is system being developed? What will be the done? What are the objectives? What are the goals of the project? What are the scope of the project? How much is the schedule? When it will be done? Who is responsible for function? So responsibilities of each team members and their roles are clearly defined. Where they are organizationally located, they are co-located teams or they are distributed teams, or it's a outsourcing or commercial off-the-shelf system or third-party software development is there. How the job will be done technically and managerially. So management and technical strategy of the project is established or not. How much resources are required in terms of infrastructural resources, in terms of team members size. Thank you very much. Jazakallah khair. May Allah bless you. Assalamu alaikum.